Let's jump right into this explainer on the Python basics for SHAP. If you spend any time working with data, you know models are incredibly powerful. But honestly, understanding how they actually make their decisions under the hood, that's the secret sauce. That is exactly what sets great data scientists apart from the rest of the pack.
Picture this. You're presenting a brand new customer churn model to your manager. You're super proud of the accuracy metrics, and then, boom, they hit you with this exact, incredibly common business question. Your model predicts a customer will churn, but why? They don't just want the output, right? They need the reasoning. If you can't answer the why, well, your model might literally never leave that presentation room.
And this perfectly highlights the crucial difference between merely predicting an outcome and actually understanding it enough to make a real strategic business decision. Look, a prediction just tells you what's going to happen. Like, hey, a customer is leaving your platform. But a decision tells you what we should actually do about it. Because if we don't know the exact reasons why they're leaving us, we can't offer them the right discount, we can't fix that specific bug they hate, or send the right retention email. It's like flying blind.
So to get us to that decision-making level, here is our roadmap for today. We're going to cover 1. The black box problem. 2. What are SHAP values? 3. The Python implementation basics. 4. Reading SHAP plots. And 5. Why SHAP matters.
All right, kicking things off with part 1, the black box problem.
Complex algorithms like deep neural networks or ensemble trees, they are notoriously opaque. It's frustrating, but that's where explainable AI comes in. It's basically the bridge between a super complex, unreadable algorithm and actual human understanding. And let me tell you, this is absolutely vital for any real-world business application. It literally turns a mathematical guess into a trusted business tool.
Okay, moving right along to part 2. What are SHAP values?
Enter SHAP. The absolute crucial point here is that SHAP values help us assign a very specific weight of responsibility to every single variable that went into our model's prediction. Think of it kind of like a group project at school, right? SHAP uses game theory to tell you exactly how much credit, or let's be real, blame, each individual team member deserves for that final grade.
And when you look at feature contributions, you'll see how it basically pits variables against each other. So in our churn example, maybe something like high engagement is a positive force, right? Pushing a customer's loyalty score way up, while an unresolved support ticket totally drags it down. SHAP visually balances these tug-of-war forces to show you exactly what is driving the final outcome.
Let's jump into part 3, which is really the core focus of this explainer, Python implementation basics.
Think of this as your hands-on mentor checklist. There are really just 3 fundamental steps to generating these insights. Load the model, create the explainer, and generate the plots. It's incredibly streamlined once you actually know the workflow.
So, step 1, it's super straightforward. You simply load your pre-trained machine learning model right into your Python environment. Now, this could be a scikit-learn random forest, an XGBoost model, or even a PyTorch neural network. You've already done the heavy lifting of training and validating your customer churn model, so now you just need it active in your workspace, ready to be analyzed.
Step 2. The syntax here is incredibly simple once you've imported SHAP. You literally just wrap your loaded model inside the SHAP explainer object. Depending on your model type, you might use a specific module, like a tree explainer for your random forest. But basically, in just one line of Python code, you're attaching an explainable AI diagnostic engine straight to your model. It's pretty amazing.
And finally, step 3, we pass our actual data set through that explainer. What this does is generate a matrix of raw SHAP values. You get one for every single row and every single feature in your data. This matrix is the absolute fuel for all your downstream visuals, calculating those game theory contributions for your entire churn dataset.
Moving right along to part 4, reading SHAP plots. Generating the data is one thing, but reading it is another. Calling a SHAP summary plot gives you a global explanation. This is your overarching view of which features are most important across your entire dataset. You might notice how a feature like, say, monthly subscription cost drives the most behavior overall, while something like newsletter open rate barely even moves the needle. This macro-level view is exactly what dictates your overarching business strategy. But we have to go deeper. It's critical to understand the difference here. Global shows you the big picture of how the churn model works, while local zeroes in on why one specific customer is at risk of churning right now. By running a SHAP waterfall plot on a single row of data, your team can make a completely micro-targeted, personalized intervention for that exact user. That's a huge game changer.
And lastly, wrapping up with part 5, why shape matters.
Let's connect this back to the real world. Companies rely heavily on these exact SHAP explanations because in high-stakes fields, think banking, fraud detection, or healthcare AI diagnostics, a prediction without a clear, explainable reason is totally useless. Honestly, sometimes it's even a legal liability. You can't just tell a doctor a patient is high risk without explaining the biological markers driving that prediction, right? And the exact same logic applies to your customer retention strategy.
So I want to leave you with this thought to reflect on. How will mastering explainable AI change your value as a data scientist? If you can apply these Python basics to not just predict the future, but actually explain it, think about how much more valuable you become to your team. You transition from just being someone who writes code to becoming a true strategic partner in the business.